In this video, I'll show you how to use Home Assistant, n8n, and OpenClaw, all running in Docker, an isolated environment, to forge your very own 24/7 private real-time location tracking system. All right, let's get started. The foundation of this system is the OwnTracks integration. First, head over to Home Assistant. Go to Settings, Devices and Services, hit Add Integration, and search for OwnTracks. The moment you submit, Home Assistant will generate a webhook URL and an encryption key. Copy both immediately. Now, here is a critical technical point. When you install the OwnTracks app on your phone and switch the connection mode to HTTP, you'll see that the webhook is an internal address. Even if your phone is on the same local network, it often cannot communicate directly with Home Assistant using this internal IP. You need to use a public domain or a service like Tailscale to make that URL accessible from anywhere. Once that's configured, go into the app's advanced settings and paste your encryption key. By default, the app sends coordinates every 60 seconds, but you can modify this upload interval to suit your needs. With data reaching Home Assistant, we need n8n to handle the requests. We're building a straightforward 3-node workflow. First, we have the webhook node, which acts as the trigger for our automation. Its job is to create a unique URL that waits for a signal from the outside world. In the settings, we've set the HTTP method to post and the path to track. From here, be sure to copy the production URL, as this is the specific web address we need to provide to OpenClaw. The moment OpenClaw sends a request to this link, it tells n8n to start the location tracking process immediately. Next, we have the Home Assistant node set to Get a State. Its job is to pull live information from your system. In the settings, we've specified the entity ID for our device tracker, which is the one linked to OwnTracks. By doing this, n8n can instantly grab your phone's current latitude and longitude, providing the precise coordinates needed for the final stage. Finally, we reach the Telegram node set to Send Location. This delivers the final result to your phone. In the settings, we provide our specific chat ID and use expressions to map the latitude and longitude we just pulled from Home Assistant. We configure it this way to transform raw numerical data into a visual map message. This allows you or your AI agent to see exactly where the device is located within a single Telegram notification. And that's it. With just 3 nodes, you forged a seamless private link between your AI agent and your real-time location. To make this system interactive, we need to give OpenClaw a new skill. Open your Telegram bot linked to OpenClaw and use the Skill Creator tool. I'm providing a structured prompt to create a skill that triggers our n8n webhook whenever the keywords location track are used. OpenClaw will generate a dedicated folder for this skill. Let's jump into the OpenClaw container to look at the files. Inside, the skill.md file acts as the AI's manual, defining the trigger patterns. There is also a scripts folder containing a shell file. This is the execution logic, a simple curl command that sends a post request to our n8n webhook. For the final test, I'll type location track into the bot. OpenClaw recognizes the command, executes the shell script, and the real-time map appears in the chat. The real power here is that OpenClaw supports scheduled tasks. You can tell the bot to create a cron job for this skill to run every hour. This allows you to automatically track your location 24/7 without any manual input, all running within your own isolated environment. By the way, I've bundled everything from this build into a guide for you. You can find that link waiting in the description. I'm always looking for new ideas, so share what you'd like to build together in the comments. Every like and subscribe truly helps the channel expand. Thanks for watching.